Hello and welcome everyone, and thanks for joining us today in a new episode of Let's Talk About Data Show. It's a new week, new guests, a new topic, and as always, it's data related one. I am Ibrahim Amara. I'm a database specialist solutions architect, one of your regular hosts. I'm based out of London, and today we have another interesting topic to discuss with our guests here. So today we are going to discuss about how you're going to leverage and use the different cloud native tools like the AI tools and machine learning to address or resolve a problem related to the multi-tenancy in Aurora MySQL. And for that, I'm really pleased to have both Ranjini and Simon with me today to discuss this topic. So let me ask Ranjini, can you please give our viewers a brief about yourself?
Hello, greetings of the day. I don't know where you are all based from. It's afternoon here in London. Yes, I am based out of London. I'm Ranjni, Associate Specialist Solutions Architect. I've been with AWS for the past almost like 3 years, and I have experience in handling conversations related to RDS and Aurora MySQL. And I have experience on data engineering and ERP consulting as well. So that's about me.
Hey,
Excellent,
I'm
Ranjini. Simon?
Simon. I'm Simon. I'm an RDS MySQL and Aurora MySQL Specialist Solutions Architect. Try saying that 3 times quickly. All in, I've been at AWS. I am just under a week away from 10 years. So I've been around a while. The three of us are all on the same team, although we
Exactly.
focus
I was
on
going to
slightly
say
different
that.
things.
Yeah, I was going to say that. We are part of the same team. Yeah, as Simon was saying, we are just handling different or focusing on different engines, but we stand in the same team. Great. Thanks a lot, Ranjini and Simon, and for our today's topic. So you were talking about the multi-tenancy in Aurora MySQL and how you're going to manage or unravel the problems or the issue of monitoring or managing the multi-tenancy in Aurora MySQL. But before going to this, let me start by asking you, Ranjini, about the Aurora MySQL itself or the Aurora as an engine. What makes it unique? What makes it different from the traditional or classic RDBMS engines?
The difference in Aurora lies in the design itself. Aurora has been designed to provide high availability by design itself. There is a decoupling between the compute and the storage layer. In traditional databases, how they are working is there is an instance and a storage layer that is tightly coupled. But in Aurora, there is a decoupling between them, which lets it scale independently of each other. And the storage layer by itself is highly available, meaning that when you write something into the database, it's not just one copy that is being saved by Aurora. There will be 6 copies of those data that will be available, highly available and highly durable as well. There is self-healing capability that Aurora has. That means the storage nodes that act behind to store your data will be communicating to itself. If there is any data that it needs, it will be communicating to other storage nodes, getting those data and synchronizing it. And Simon, would you like to add anything?
I mean, you pretty much covered it. I think kind of one of the only things that we haven't kind of touched on so far is because of the decoupling of the storage, when you do it right, you're writing to 4 out of 6 of those storage nodes. So even if there is a latency penalty on one of them, you're basically ignoring that one and still writing to 4 that's operating within the expected parameters. So even in the unlikely event you do experience kind of latency from a hardware perspective, it isn't something you're likely to experience as a kind of foreground operation whenever you're writing to the underlying data files.
And all of that without any interference from the user or the customer. So once they provision the cluster, even if it's just a single instance, right, they will be getting these 6 copies, this high availability and durability at the storage layer.
Yep.
That is
Right.
correct.
Okay, perfect. Okay, before moving on, I'm just want to see some of the comments here. We have Vector. Hello, Vector, and we have Prasad, our regular host. He's also today supporting us on chat. So if you have any questions, just send it over, and and Prasad will be helping with those. That's hi everyone. Hi, and Crazy DB5, one of our regular viewers as well. Hello, oh, great topic. Thanks a lot. And he, she, or he's based in Mumbai. That's great. And okay, also Prasad shared a link to the uh, Aurora overview, so that we give you an overview about the Aurora itself and the architecture of the Aurora and the high availability. Perfect. Okay, so back to the topic again. Um, when you are talking about the Aurora MySQL multi-tenancy, what we are referring here to, does this mean that having multiple sessions at the database level, having multiple databases, and what problem that we are trying to solve?
Who do you want to send that to? Me or Ranjini?
Yeah, it's up to you. Maybe you can go.
I'll take it then.
Okay.
So, generally speaking, we're talking about having multiple different tenants. So, for example, you'll have multiple different customers, for example, that all have the same series of tables. So, in the example Ranjini is going to show later, we'll demo what this actually looks like. But you can think of this as any kind of database where you might have multiple people accessing their own copy of a schema that'll look pretty much the same across n number of customers or n number of users. So we're talking about it primarily from a schema perspective with a set series of tables, and more specifically in terms of how to manage the fact that MySQL and by extension Aurora MySQL doesn't kind of natively give you something like Linux C groups where you can basically cap resource utilization on a per customer or per tenant basis.
Okay. So this is a problem that we are talking about, something like the noisy neighbors or something like that. So if
Essentially, yes.
okay, so if one session of or one user is hogging the CPU or consuming most of the memory, then they will not allow the others from using the database in an efficient way.
Yeah.
And natively, there is no option from the MySQL side to identify these sessions or to find out the utilization.
You can do it, but you kind of have to build in some guardrails yourself. So, for example, MySQL will allow you to cap the number of connections you have on a per user basis, but that
Hmm.
also assumes that you have a different user for each one of those tenants. At the same time, you can also see what each user is doing. Again, similar principle. If you're using a different user for each tenant, that'll let you see what the individual sessions are connecting and by proxy what queries they're running. But that won't by extension show you, oh, this particular tenant is using, let's say, 10% CPU or a certain amount of IOPS, or more specifically, the amount of memory, which is going to be kind of the primary focus of what we're going to talk about today.
Okay. So right now, are there any tools that the customers are using to track such the consumers or the different tenants?
Yes, but they're not sort of specific tools to this problem. They're this sort of tools that we'd use for general monitoring, and this is
Hmm.
kind of a subset of monitoring or observability. So you have things like enhanced monitoring, you have things like performance insights, you have things like performance schema, CloudWatch metrics, CloudWatch alarms, exporting logs to CloudWatch, and then doing filtering, whether this is some sort of manual batch job or built-ins for CloudWatch logs, and then trying to break it out that way, where it's a bit more reactive, where I see a particular symptom or a particular amount of resource utilization, and then I reactively do X, Y, Z with the tools that I have at my disposal to try to kind of dig deeper into this. Note that this will be mostly after the fact. So some sort of things you're going to need to have integrated tooling. So whether this is performance insights or some sort of third-party tooling, you're going to need to be able to see historical information about what's happening. So the performance schema in MySQL is really good for letting you see what's happening right now. There is a history version of that table that'll give you a little bit longer than right now. But usually this problem kind of manifests itself more, oh, what happened yesterday or what
Yeah.
happened last week? And that can be a lot harder to do if you're only using the kind of native inbuilt primitives inside of MySQL, which is trying to give you, okay, this is what happened now, or this is what's happened cumulatively since the last sort of restart, if we're talking MySQL level counters.
Okay. So in this case, you're just having an overview about the resource consumption, but you don't know which session, which user did what. So it's just and a cumulative overview, as you mentioned.
Yeah. So, for example, you can see counters in MySQL that'll show you the amount of, say, inserts, updates, or deletes that happened. But that'll be since the last restart, and it will be across everything that exists in the database. So, for
Hmm.
example, if you have 10 tenants, that entire workload could have been caused by one tenant, or it could have been evenly distributed across all 10 of those tenants. At least from that counter alone, there's no way to tell. You also can't tell if it happened yesterday or if it happened 6 months ago, assuming the database has been running continuously for the last, let's say, year.
Hmm. Okay. So, and that's why we have this solution now, right? So, Ranjani, if you just give us an overview about the solution and what exactly the solution is solving, or how the output, how does it look like?
Okay, as a means of illustrating the scenario, I would like to bring up the implementation on the screen.
Okay.
We have created a dental clinic app. So, as we are solving the SaaS problems, this is a dental clinic app provider that we have taken into account. There could be several customers that the dental clinic app provider will be having. For example, let's name it as Bright Smile Dental Clinic or Bright White Dental Clinic, etc.
Hmm.
The naming conventions can be different.
Okay.
So there are many means of how the SaaS providers they can store this data into the database. One such commonly used method is the schema based multi-tenancy. So one
Mm.
customer will be occupying one schema in the database. So for this example, we have used dental clinic 0xx, that's the naming convention. The first dental clinic chain will be occupying the 001. Dental clinic 002 will be a second dental clinic, and so on. In total, we have 20 such dental clinics who are taking part into our example. And there are 8 total tables in all the 20 different dental clinics that we are using, one for the appointment, one for the clinics, inventory, patients, payments, prescriptions, staff treatments, etc. If we are writing something into the database, for example, if we have a new patient coming into the clinic, you are using an insert statement, then this will be populating the buffer pool being the in-memory structure of MySQL InnoDB engine. And if we are trying to query out something from the database, select staff from inventory or select staff from the treatments that they have got braces. So all those details will be in the treatments table. So all these activities, whether they are insert or the read activities, buffer pool will be populated. So assuming these activities are already recorded into the buffer pool, there is a notebook instance. Okay, yeah. There is a notebook instance that is up and running where we can run the notebook in order to identify what is happening within that buffer pool. So I'm not really showing how the data is ingested into the Amazon Aurora because this is the solution that we are going to present. The Amazon Aurora instance will be having all the populated data there in the buffer pool. The Jupyter notebook will be querying the Aurora instance in the buffer pool table. With the help of AWS Secrets Manager, it will be not hard coding any credentials, it will be just retrieving the secrets from it and will be connecting to the Aurora instance. Now, the SageMaker AI notebook, which will be running, will be providing two solutions for us. So, the number one solution is the buffer pool analysis. So, in the other monitoring techniques, we'll not be able to identify which is the noisy neighbor, as Simon already mentioned. So, there is dental clinic, Bright White Dental Clinic, which has high number of patients. They are having different number of activities. There are new users coming in, and every time there is high activity. But due to this, there is a high resource contention that is being experienced within the Aurora cluster. But using the solution will be identify, yes, this is the particular schema, this is the particular customer that is having high traffic, and we need to have a particular resource allocation, or we can separate out this particular customer out to a different Aurora instance, or we can scale up the instance, etc. So depending on how the result has been provided by the buffer pool analysis, we'll be able to make an informed decision whether to scale more or separate out. And the solution also provides a means to charge back the customer. So if you are having the same set of billing that has been applied for different clinics, then if there is a customer that's creating more noise, you can charge back more to that customer who is accessing the resource continuously. There will be other customers who will be accessing this instance, Aurora instance, with a low traffic. So they can be charged at a minimal amount, etc. So I'm just giving out ideas how this
Yeah.
solution can be extended. So
So based on this analysis, you can automate an action or a corrective action based on that, whether whatever, as you mentioned, you can charge them more, or maybe you can decide that you want to increase the size of the instance, for example, something like that. So some automated actions or corrective actions can be taken as well, right?
automated, or you can just have the analysis in your hand and you
Mhm.
can do it manually. So that
Okay.
this implementation of solution is up to the customer how you want to do it. And
Okay.
now the,
Yeah, before moving
Mhm.
over to the next point, I want to ask Simon about how a contention like this will be manifested, the contention of the buffer pool or the buffer cache, what the symptoms that the customers will be seeing.
So if we assume for the sake of argument that the buffer pool is going to be roughly 75% of the total memory of the machine you're running on, that's kind of a general rule of thumb. The larger the instance is, you might want to go a little beyond that threshold. If it's smaller, probably want to keep it around that threshold. So you can basically think of this as the primary area where you're going to be accessing data,
Mhm.
especially for your primary part of your workload. So for example, let's say I run a select query to find a patient name. So first name, surname. In an ideal world, I want that data to be held in memory and not have to go to disk to pull that data.
Mhm.
That's primarily what you're going to be using the buffer pool for. There is a write component to it, but I'm kind of setting that aside for a second. So when you populate the buffer pool with, let's say, 12 gig of data out of a potential 12 gig, you're going to be having to move data in and out of memory if new things are being consistently read. So, for example, if one customer is consistently reading the same data over and over again, you want it to be in memory. But if a particular tenant is reading lots of data over and over again, they're going to be consuming a disproportionate amount of memory. And disproportionate doesn't have to be in terms of the overall amount. It could be based on the tier that you have them segmented into. So let's say you have a multi-tenant application where you have some free tier customers, you have some business customers that pay a small amount of money a month, but not that much, and then you have your kind of giant enterprise customers. And let's say you have 10 customers on a box. This is a bit of a contrived example, probably not how you would do it. You don't want your free tier customer consuming, let's say, 10% of your memory, and then there not being enough as much left over for the enterprise customers who are paying more. So it might not be that they're using, let's say, 60, 70% of a resource, but they're using a amount of that resource that is disproportionate to the amount that they're actually paying for it. And this kind of goes either
Mhm.
way. So it's
Mhm.
going to depend on which customer and it's going to depend on which tier. As Ranjini already mentioned, this is potentially an indicator of actually maybe there's a particular customer that we want to move off that particular box. So in the previous example of, let's say you've 10 customers, let's say two of those customers are your enterprise customers. Maybe you want to move those two customers where the back end database is used by just the two of them. So the amount of resources that they have to go around is much higher and it is much more kind of appropriate for the amount that they pay versus you might want to densely pack more free tier customers onto the same database backend. And if they have a kind of a degraded level of experience, you might be willing to kind of put up with that because they're not paying anything for it. So their expectations are obviously going to be lower than if you have some sort of agreement or arrangement in place where you're kind of contractually obligated to provide something of a certain quality within a certain time frame, whatever way that kind of SLA shakes out or SLO.
Yeah, makes sense. Sorry, Ranjini, back to you again. Yeah. So the solution, the first part, you mentioned that there would be a Jupyter uh, runbook that will extract information from the Amazon Aurora MySQL database, information about the buffer cache usage, and then you will use Bedrock to do some analysis, and based on that, it will give you the output of this analysis, and then it's up to you to take a decision.
The buffer pool analysis mainly is done using very simple Python um, commands and machine learning algorithms. So that's the output of buffer pool analysis,
Hmm.
the workload that has been grouped into different groups, high, medium, and low noise customers. So where the bedrock comes into picture is in the solution too. So, based on this categorization, we can pass what are our findings from the buffer pool analysis, and based on that, we can create the prompt and pass the solution, pass the question to the bedrock. We can invoke a model asking, okay, what should we do for the high workload customer, or what should we do for the medium workload customer? What are the troubleshooting steps? What are the steps to monitor? And what are the parameters that we can set in order to calm down the instance, etc. So the bedrock will be providing a response as part of the solution, and this is the final output that we will be getting from the solution. The buffer pool analysis and workload grouping from the part one. From the part two of the solution, it will be the AI recommendations from Bedrock.
Okay, got it. So it's not only the analysis, but also the recommendations for what to do next based on this analysis. Okay, that sounds really nice. And so for some of the solution like that, I see the main idea is to get information about the buffer pool, and then I believe the rest of the solution is generic, can be applied to different engines, right? Or is it specific for MySQL?
So, assuming the database engine that you want to adapt, if the database engine has the means to identify which table or schemas are creating, are having high read or write activities, then we can have a query which can capture this information and just replace in the solution and have the same analysis that can be carried over. Yes.
Yeah, I know at least for, yeah, even for both Oracle and Postgres, for Postgres, the extension for that, and for Oracle natively, you can run queries to get the details of the buffer cache, the tables that are loaded there, the number of blocks and stuff like that. So I think you implementing the same concept, you can do the same thing, do the analysis and get the recommendations as well.
That is correct. The per table, per schema information, if that is available, then it should be possible to extend the solution to Postgres as well. That's correct.
Okay, perfect. And for the Bedrock, so you're using LLMs for that. Which LLM model you're using?
I have used Claude 3.5 Haiku.
Mm-hmm. Okay. And is it the recommended one? You can use any other LLMs as well.
So the solution is currently compatible with Anthropic Claude 3, but this can be extended. There is nothing that stops you from trying out with the different LLMs. There could be difference in the command or how the model can be invoked. There are links that are available in the Bedrock runtime documentation. There are codes available for different Python and whatever SDKs that you would like to use. All the commands are available there, so you can just replace with um, your prompts, your HTTP text body, and you will be able to invoke the model. You will be able to get the response.
Okay. Okay. Before continuing with that, I'd just like to say hi to some of our viewers. Data Whisper, hello, tuning in from UK. Hi, Data Whisper. Crazy DB5 looks interesting. Thank you. And also Prasada shared a link to the multi-tenancy on Amazon RDS. Okay, so any best practices for our customers who are using this solution?
I
The
can take
first
that one, or
moving
you can.
No, before moving to the best practices, I'd like Simon to answer what are the downsides to using the InnoDB buffer page that we are using for this solution.
Okay, there are downsides. Okay.
Yeah. Okay. So fair enough. I'll
We
take
didn't
that.
agree on that. Okay.
Essentially, in MySQL, it's a bit of a catch-22, bit of a double-edged sword. The way you get this information is running a query against InnoDB buffer page. The problem
Mhm.
with running a query against that is it's a mutex on the buffer pool, which everything is accessing. So it has the potential, especially in a production environment, especially under heavy load, to essentially cause a stall. There
Mm.
are ways around this, but they all have their own kind of pros, cons, and trade-offs. So this is the only place you can get that information in InnoDB. So you can't just query a different table that has a lower impact. You can query that table at a quieter period of the day. The obvious downside to this being that it won't give you as accurate of information because it'll show you what the data held in memory at that particular time looks like. So back to Ranjini's example with dental clinics, let's say you have dental clinics that are around the world. You might have a tenant show up as being the kind of heaviest user just because it's between sort of 9 a.m. and 5 p.m. in a specific time zone. And actually, the kind of heaviest user over a 24-hour period is just most of the people who would be visiting are now at home sleeping at this period of time. So it is a workaround, but it is a trade-off. Additionally, there are other ways you can do it where if you can mirror your production traffic, so there's different ways to do this. There's some database level proxies that'll do it. There's some kind of application layer proxies that can do it. There's alternative ways you can do it if your application is very kind of API driven and you can replay all of the API calls from like a previous day, you could run it against another machine and kind of actively simulate production. So now you can effectively run the same setup against a duplicate environment. You get the accurate data at the time you want it, or the ability to run it multiple times a day to check in at different periods of time without that downside to the kind of the mutex on the buffer pool. Because the mutex in the buffer pool is going to be somewhat relative to how big the buffer pool is, because it essentially needs to scan the
Mhm.
entire contents. The bigger your database is and the bigger the buffer pool is, the more problematic that mutex becomes. If you run it against something with, let's say, an 8 gig buffer pool, it's going to be different than if you run it against something with a terabyte buffer pool. The amount of time it takes is going to be a lot longer.
Yeah, and I believe it also depends on the frequency of running the query like this. And of course, the lower the frequency, the higher the accuracy, but the
Yeah.
higher and you might run into this problem of stalling. And so there's no, because I believe in Oracle, it's being there's like a memory structure where you have all this information in. So I'm not sure if it actually would go through scanning all the entire buffer cache, but I think it updates this memory structure with these details. But it seems that for MySQL, there is you have to scan everything, and as you mentioned, you have to acquire this mutex in order to scan, and then yeah, that might throttle the application or the queries against the database. But it's always, there will be always a trade-off. If you want high accuracy, then you might want to accept this risk, and you can tune the frequency of running it.
Yeah. As an FYI, there's a question in the chat. If you want to pop it up, we can take that before we move on to kind of the next topic of where Ranjini was going before we went kind of sideways on it.
Yeah. Okay. Just sorry, I got distracted. So Crazy5 was asking, sorry, wouldn't be pages be replaced with LIU if not queried at specific intervals?
Short answer, yes. So essentially, whenever MySQL loads data into the buffer pool, it has a thing called midpoint insertion. Basically, it doesn't go to the very top of the LRU list. It will make its way further and further up that list if it is queried more and more frequently. But that's kind of why I was touching on the point of if you, let's say, for example, you run a MySQL dump, which will just cause lots of scanning.
Yeah.
That'll kind of churn through what's in the buffer pool. At the same time, if you have a kind of follow the sun model where you have dental clinics around the world, then one location going offline and another region coming online, you're going to have them reading data and it's going to override what's in the buffer pool and the old stuff will be kicked out, which is why I was saying that there's trade-offs of running at different times. Now, if all of your customers are in one location so that the times things are being accessed are going to stay consistent and you're not going to have that kind of overnight swap to a different region, then that kind of level of churn is going to be different and you're not going to have things that get aged out in the same way that you would if you had different kind of region support. The screen at the minute is basically just showing on the right-hand side of the screen, you've essentially got that midpoint insertion that I was touching on and kind of the head and tail of the old and new sublist for the buffer pool. And this goes into Crazy DB5's question. And then on the left-hand side of the screen here, we have the structure of the table that we're going to query against, which is InnoDB buffer page that I mentioned earlier. We're not going to go through each one of the individual sections. Ranjini kind of touched on the fact that there's multiple different buffer pools, which is what the first one's on about. And then as you go through, you can see things related to page modification, oldest, newest, table name, when it was accessed.
Perfect. Thank you. So back to you again, Ranjini. Best practice.
Yes, the reason why I directed that question to Simon, because that was the number one recommendation in the best practices, to have the solution run in a mirrored environment. And since the second solution solely focus on the recommendations from the bedrock, it's important to identify that the prompts that you use, that will be pivotal in the response that you will be getting. So it's good to have prompt engineering, good to have different sections. What exactly do you want? Be precise as possible. If you are asking generic questions, then you will be getting a generic answer, but be as specific as possible with the ask. If you want troubleshooting steps, if you want any parameters that needs to be provided by the bedrock as a recommendation, if you want a particular uh, monitoring technique or anything, just be specific in the prompt itself, then you will be uh, receiving that response accordingly. And you can test with any other LLM, whatever works for you, you can use with that. Just that the request and the response, the invoke model, the commands will be differing for the different models. It could be different, so just pay attention to the commands that are available in the bedrock runtime. And
Perfect.
yeah, there is one more recommendation that I would like to mention. So, in order to increase the accuracy of the recommendation, there could be several outliers, meaning that there could be one particular customer who is having high memory usage. There would be several having very low, but there could be um, maybe five or six such groups that are falling under the medium, but they are not exactly the medium category. There would be a disproportionation in their memory usage as well. You can try increasing the k value in the k nearest neighbor algorithm, and you can provide labels for them as well in order to have a more accurate or
Mhm.
more fine grained resource allocation groups.
Got it. Perfect. Okay, for those who are joining us now, we are discussing using the different AWS AI and machine learning tools in order to investigate the problems related to the multi-tenancy in Aurora MySQL and how to identify the tenants with the highest consumption or the different consumption patterns and how to get recommendations on that. And I believe it's the time for the demo, right?
Yes, all good.
Sure. Okay. Before going to the demo,
Mhm.
do we have like a code that can be shared with our viewers as well for this demo?
We are hoping to have the code available in the AWS samples in a few weeks.
Okay.
So
Perfect.
it will be updated in the Twitch link.
Okay. Perfect. Yeah, for our viewers, once the code is available, we'll be adding it to the community pages. And I believe Prasad will be sharing the community pages as well with you so that you can check the past shows and see if you have any interesting shows that you want to uh, check again, or if you have anything else that you want us to discuss, you can connect to us and you can send us an email. Okay, back again to the demo. What we have here, we have an Aurora cluster, right?
Yes, what we have here, I'm going to show and show this diagram. So we previously visited. We'll be querying the Aurora instance. Yes, Ibrahim, you're right. This is the instance that we are going to query, the TFC instance one.
Perfect.
Yes, and this is the notebook instance, Aurora cluster analysis, which has the Jupyter notebook available. And this is the Jupyter notebook that you are already seeing on the right hand side. And before running the notebook, please make sure you have the model access to whichever model you want to test this out with. So currently I have access to Claude 3 Sonnet and Claude 3 Haiku. So if you visit to Amazon Bedrock, you can request for model access by scrolling to model access and request for the access.
Nice.
Now over to the solution. The first step here is to install the necessary packages. I have here the requirements.txt, which are having the necessary libraries that we need to import into it. Install the packages and import the libraries. Okay, let me do one thing. I'll just run all cells and go through them.
Okay.
Yeah. Yes, it has installed the packages. Now we are importing all the necessary libraries. Okay. Yeah. This is where the Python notebook will be accessing the secrets from the secret manager. It will be acquiring host, user, password, port into db config. This is the query that we have used, which will be giving a per table and per schema uh, detail of the InnoDB buffer page. This is the table that we have used. And once the connection is established, we read from the connection to the data frame. This is the output of the query. There are 20 table schemas, as I mentioned earlier. This is a dental clinic app. We are having different schemas. So, dental clinic 001 is a customer. This is a different customer. So, all these schema based multi tenancy provides isolation for the tables underneath it. And this is the schema wise buffer pool utilization. So 001 has 13 MB usage in the InnoDB buffer page. 008 has 25. And there is one dental clinic 012 which has very high utilization. And there are this also returns the table count, how many tables have been hit in total using the insert or the select queries, etc. And the total records that are already present. In order to identify, we are using several visualizations. So this is just an example of 20 such schemas. So what if you have 200 or 300 such schemas or databases, user databases within your single Aurora cluster? It will be really challenging to go through the whole list and identify which is having high utilization, which is having moderate utilization, or which is having the disproportionate utilization. Yes, that's the word, disproportionately consuming the memory. So, using different visualization, we'll be able to understand okay, there are certain anomalies. This is the
Mm.
buffer pool usage distribution using box plot. Using this box plot, you will be able to identify there is an anomaly. there is something that is disproportionately consuming your buffer pool. This is the histogram visualization using which you will be able to identify what are the different categories of the memory usage. So there are many schemas that are utilizing very low memory. That's why the count is high. So if you are having 200 or 300 such schemas within your database, you will be able
Mm,
to see several um, dips and peaks. In order to do that, there is a smooth curve which will be able to give you a kind of visually smoother look, to give you an idea about, okay, there are medium noisemakers within your schemas, or there are small number of schemas that are disproportionately using high memory. And coming to the scatter plot, this will give you a comparison between the buffer pool versus the total records. So this is a linear relationship that you are able to see if you are plotting the buffer pool MB versus the total records that are there in the buffer pool MB. And here, even when we are plotting these points, I'm not really sure if you are able to see this yellow dot. So this will also give you an
yeah.
indication that there is a schema which is able to occupy high space within your buffer pool. So for customers, this will be something to look at, because your instance has been completely taken over by, or the high memory consumption has been taken by one such schema. So your other small if your other schemas are having moderate to low utilization, then this is something that you will need to look at. What is going wrong with this schema? Is it high usage, or is there something to look at, or does this customer need to be separated out of this database in order to have that individual scalability for their usage? As Simon mentioned, this could be an enterprise customer and they have high utilization, and they can be charged differently as well. So
All
what
of the data, all of the data, they are being analyzed on the spot, right? They are not being
that is correct.
stored. So,
That is
is
correct.
there a possibility to store them so that we can have like a historical reference of these all of these information? Um,
You can store the output of this query into uh, CSV if you would like.
yeah, and maybe to an S3 bucket or something like that, and then we'll have
Yeah.
like a historical reference for today. Okay.
And next is the step where we'll be detecting the outliers. So visually, we are able to identify there are some anomalies within the analysis, within the buffer pool analysis. Now, we'll be using statistical methods in order to detect those outliers. We have used Z scores, standard deviation, and interquartile range. So, talking more about the statistical methods, standard deviation is a measure about how spread out your the numbers are in a data set around the mean value of the buffer pool usage. So I'm talking about this context. And now the Z score. Z score is a measure about how many standard deviations a data point is from the mean. And there is interquartile range. If you order all the different schema outputs into an ascending order, we'll be able to identify the different quartiles, the q1, q2, q3, q4. So that's the 25th percentile, 75th percentile, etc. So this is the formula for the IQR calculation. So I'm not going deep into how these are
Mhm.
calculated and how these are different. We'll be able to see how the difference lies in the output.
Okay.
Next is the calculation of the deviation scores. We'll be able to see more in the output where we'll be seeing the prints. Yeah, now this is a basic understanding about the what the buffer pool looks like. So this is by using the describe function in Python. This is a simple command, df.describe. The output will be showing how many counts of schemas, what is the mean of the buffer pool usage, what is the standard deviation, what is the minimum value, what is the maximum value, etc. And the different quartile regions. So this is the 25th percentile of the buffer pool distribution of the schema, and the 50th percentile, 75th percentile. If you're ordering from in an ascending order, the 25th percentile value is the 4. You can see that 25th to 75 there is not a significant increase, but you will be able to see after 75 the max value is 60, meaning that there is a sudden increase in the value of the buffer pool usage, which is after the 75th percentile, meaning that there are less number of schemas that are
Yeah.
occupying high memory utilization. And this is the buffer pool usage analysis report. Using the Z score, Dental Clinic 012 has been identified as high memory utilized 1, and Dental Clinic 012, this is again 60 MB. Dental Clinic 012 is 60 MB again.
So using the different formulas, you've reached the same conclusion. This is the same clinic that's consuming most of the buffer cache.
That is correct.
Mhm.
So depending on whether there is any other schema which is having moderately high utilization, you will be able to see a bit of differences in these calculations as well. It
Mm.
all depends on whether that particular method is having high influence due to the outliers or not.
Okay.
So this is the buffer pool analysis report, the impact analysis, mean without mean with outliers. So the buffer pool mean is currently 11 MB. So if the schema which is creating the
Okay.
60 MB utilization is removed
Mm.
out of the cluster,
Only 11
this,
then.
yeah, this is the mean it will be having.
Yeah. Okay. There will be a drop in. Okay.
And this is the traffic categorization into high, medium, and low. So this categorization has been formulated by the standard deviation and the z-score. So there is one uh, high schema, high noise making schema, and there are several number of medium schemas that are present here. So this is all computed using the mathematical or the statistical methods. Now we'll move on to the step where we'll be incorporating machine learning algorithm to analyze the workload and find the different groups and classify those workloads. For this, we are using the k-means clustering, and in order to group them into the high, medium, and low buckets, we are using number of clusters equal to 3, and we are providing label for each of them: low, high, and medium.
So, Ranjina, I know that there is an integration between the
Mhm.
Aurora and the different cloud native services like the Lambda functions, like the different machine learning tools that we have. Is it possible to run this code directly from within the cluster itself?
Within the Aurora cluster,
So maybe like invoking a Lambda function or something like that that has the code. So
I have not tested it myself. Yeah.
okay,
Theoretically, yes. You could set up a scheduled job that runs a Lambda function that captures the output as CSV, store the CSV output on S3.
yeah,
On S3, you could invoke an event when an object's created and then,
exactly. Yeah,
for
it's
example,
like
the
a
change data.
self-contained, yeah, self-contained solution within the cluster itself. Okay, perfect. Thank you.
and this will be printing the basic statistics. This is the code for it. So if you want to hard code any particular message to your team members that okay, these are the medium schemas and they need immediate attention because they are trending towards a high utilization of the buffer pool, or if there is a schema that is having high memory utilization and this needs an urgent attention, so this is where you will be able to hard code your set of messages. And this is the output of the k nearest neighbor algorithm. So there is one high. If you remember, there were several medium earlier, so now the number has been reduced to like 5 medium
Hmm.
schemas. Yeah, and this will give you a summary about the workload level. There is one high, five mediums, low, four, etc.
Okay.
Now this is the code for the workload distribution, different workload category. Only one number of high, moderate amount of medium workload level, high number of low workload schemas. So if you correlate it with what we have seen earlier, it was an analysis of the raw data without any pre-processing. Now we have done the categorization and we are plotting those results. So that's the difference between the above set of graphs that you saw earlier and the current one. So this has the category. So you can see this as a single line because it is only one high noisemaker schema, and there are a few medium and few low, and this is the scatter plot. So for those who were not able to see the yellow dot there, so this is the blue color dot more visible to you. And print recommendation, basic schema specific recommendations for the high and medium workload, the hard coded message, and this is the output, basic schema recommendation, high workload schemas. This is the current buffer pool usage, and this is what you need to do urgently. Resource allocation needs immediate review. And for the medium workload schemas, this is how you will be able to, uh, yeah, when compared to the average, this is the usage of the dental clinic 001's memory.
So these recommendations are those the manual ones, or this is coming from the Bedrock?
The basic recommendations that are from the manual one. So these are
Okay.
all mathematical representation from the mean that is already computed earlier. We'll be able to identify how much more this current schema is occupying. So this is 1.26 times more than the mean that was computed earlier.
Okay.
Now we'll go to the bedrock recommendation part. So the above part, that is the part one of the solution, the machine learning one, and the basic mathematical methods. Now this is the bedrock recommendation. Here we are using the
Just
model.
just want to let you know that we only have 5 minutes left in our
Okay,
show.
okay. I'll
Okay.
be quick. I'll be quick.
And
Yes.
then always
Yeah.
thanks.
Yeah, so this is the bedrock model that we are invoking here in the get bedrock recommendation. In order to get the recommendation, we'll need to provide prompts. So this is the prompt, be as specific as possible. I'm providing the context, whatever your cluster is, and immediate troubleshooting steps is what I'm looking for. And these are the sections that I want to look into it: performance analysis, resource utilization, etc. And for each recommendation, this is how I would like to frame the response. I want to have the exact commands or SQL queries, etc.
Okay, so yeah, it's clear now what you meant by you need to be more specific when you are prompting it. Okay.
Yeah.
And how the okay, sorry, go ahead.
Yeah. So this is the model that I have used, Claude 3 Haiku and response body. So one recommendation here, you need to refine your prompt as well, and at the same time, depending on the tokens that you're passing to the bedrock, your recommendations will be that fine tuned. At the same time, the cost of bedrock using Bedrock also should be taken into consideration, because it will be for the for every 1,000 tokens for that particular model. So the pricing model will be different. So recommend you to just check for each model, and uh, check in the Bedrock pricing page. And the recommendation, get recommendation data frame, and here is what the Bedrock has provided for this particular high workload schema. You have to immediately identify any long running queries are there, and you have to analyze any slow query log, check the performance schema. And it has also provided the different set of documentations that you can check for as well. And the responses could be different for different LLMs that you're using. And for resource utilization check, this was the second section that was there in the prompt. And what are the steps for query optimization? So
And you can
that's
also, maybe you can also link it to your own knowledge base so that it will give you more personalized recommendations based on your own environment as well,
that is correct.
or your own run books or something like that. You maybe there is a problem that occurred before, and you solved it in a different way, or you addressed it differently, so it can learn from that and can give you a customized recommendations based on this.
So if you see one of the recommendations, it mentions setting the slow query logs and enabling
Yeah.
them. You could essentially use that for historical distribution. So
Okay.
capture the slow query logs. Let's say it took 5 seconds for a particular query. You could then see over time, both if you did nothing and or if you implemented optimizations, how that actually affected things.
Yeah. Yeah. Exactly. Perfect.
You'll be able to print out the recommendations and the traffic analysis into CSV, then text file, etc. So that's about the whole solution. So we are open for any questions in the chat window. Sorry, you know, time.
Okay. Yeah. That's looks really nice. Okay. So the output from this is that you'll be having the recommendations, you'll having all the statistics, the graphs, all these information, and based on that you can either take a manual action, or as you mentioned, you can trigger something automatically to do whatever action you want to do based on that. Okay, that's really interesting. Ranjini, Simon, I'd really would like to thank you so much for your time today and for the information that you've shared with us and the demo as well. And for our viewers, once we have the published code of this demo, we will add it to the community page so that you can access it as well. And if you have any questions, you can send us or you can leave a comment on the video as well, so that we can address it in our next shows. And we will be waiting for you next week, same time. And we will be discussing also the performance tuning with CloudWatch database insights. And we will have Prasad will be our host for that show. It will be at same time, 5 p.m. CET, 4 p.m. PST, and 11 a.m. ET. One more time, Simon Frangini, thank you so much for your time today. And for our viewers, thanks a lot for joining us, and see you next week.